Hi, dear children. Now we have finished electromagnetic wave radiation, and now you can have some idea how to construct a simple radio at home. Medium wave radio for 100 rupees, you'll get it. And you know the coil, you know the capacitance, you know the diode, everything you know there. So you'll get it. Now we'll come to a very important topic in electrostatic, Gauss theorem. Gauss is a famous scientist, so Gauss theorem. So to understand Gauss theorem, whenever there is a charge, there will be electric field in all direction. Whenever there is a magnet pole, there will be magnetic field in all direction. It is just like this. I put a water in a water balloon. Water is incompressible, so when I put much pressure into the balloon, then I will get pressure all along the surface of the sphere. All along I'll get the pressure. And this pressure multiplied by that area is known as flux. So here now, we will come now to flux. How to define flux? We define flux like this. It is the product of the normal component of the electric induction and the area over which induction is constant. That means E, electric induction, not E, electric induction into area, electric induction into the surface area. What is electric induction? Electric induction is, now, electric intensity is Q into 1. Q coulomb into 1 coulomb by K R square. Induction, you will only need to multiply E by the dielectric constant. So K Q into 1 and this K R square. So K cancel. So electric induction, K is never there. Remember, Q into R square. Now, this induction multiplied by ds. What is ds? ds is the area through which that electric induction is flowing. Is flowing outward. So that is the electric flux. That is electric flux. K into Q R square into ds cos theta. Now, you have to know a little of trigonometry. If this ds is perpendicular to this, then the flux is very simple. K into Q by KR square into ds. There will be no cos theta. But now this ds is inclined to this. It is not normal. So when it is not normal, there will be loss in area, and that loss is done by cos theta. If it is 0, then it is perpendicular, then it is ds. But it is cos theta, it will be reduced by a small amount. So this is the projectional area. So the flux is Q by K into R square. K cancels, so we get Q by R square ds cos theta. Now, what is ds cos theta by R square? See, ds cos theta by R square, if you do solid geometry in smaller class, ds by R square, area by R square is the solid angle. And the solid angle in solid geometry will be now, the complete solid angle of a cone is 4 pi. Remember that. So we'll come to that later on. So now, the flux is K into Q by KR square into cos theta. K cancel. Q by R square cos theta. Now, cos theta ds by R square is nothing but solid angle d omega. So now, that small flux, d flux, small flux over ds is Q into d omega. D omega, Q into d. Now, this is for this. But for the whole area, you can imagine this like, I think you have seen Uncle Ship, a big Uncle Ship which is not open, a big volume, and then inside the Uncle Ship there are potato chip, so the charge are here. So imagine it is an Uncle Ship container. So now the flux over that whole area of the quotient surface will be now Q3 integral sign because it is three dimension. Q3 integral of the solid angle d omega. And we should know d omega is 4 pi. So flux is 4 pi q. So remember, I want to correct some book also. They write that flux in Gauss theorem is 4 pi q by E naught. There is no E naught, there is no dielectric constant in flux. Remember that? It's simply 4 into 3.14 into Coulomb. So that is the flux. This is Gauss theorem. So what is the statement now? The statement is the total electric flux over a closed surface is 4 pi times the total amount of charge within the surface. In mathematics, it is 4 pi summation of Q. Why I say summation of Q? This is quotient surface. See a plastic volume of plastic. I just put a hole there. I blow it. So inside Q2, Q1, and Q3 charge. All plus. I forgot to put the plus. Anyway, plus Q2, plus Q1, plus Q3. So what will be the flux? It will be 4 pi Q1 plus Q2 plus Q3. So 1 is to 3 Qn. N is 1, N is 3. So this is the flux. And now, one example in IIT problem they used to give, very simple. What is the flux coming out of this sphere? The sphere is bounded by A, and A. A on X, A on Y, A on Z. The sphere is bounded, and in that sphere there are Q1, Q2, Q3, Q4 plus. And then outside that, there are Q5 here, minus Q6 here. Now, what is the total flux? The total flux is 4 pi summation of Qn plus. This is 0. This is outside this sphere. It is 0. And another one, this one is outside the sphere, is 0. So, it is 4 pi Q2 plus Q1 plus Q4 plus Q3. That is the total flux. So this example, and so you will get 3-4 marks from this, but you should know the concept of three-dimension coordinate geometry, and then you can easily score marks. And all these are known as conceptual question on Gauss theorem. I have got 4 problems on Gauss theorem. I will do them in 2 days' time. 2 in 1 day. So we will be able to answer some good question on Gauss theorem. Thank you.